Is it clear now? Can you guys hear me? Not audible. Please check once. Hope now I am audible only. So, as we have planned already, this session is intentionally designed for complete revision. Yes. So, this session has been intentionally designed for complete revision of all the subjects and how to prepare for exam. So, we'll be mainly focusing on all technical subjects under each and every formulas, important basics, concepts, everything. And apart from that, one more thing I would like to conclude. Whoever are preparing for it, especially from Tamilnadu background, if you are preparing for TRB exam, this session will be 100% helpful for you all. And second thing, upcoming exams. You will also be going to face Barc exam in the month of April first week. After that, you will also be facing all upcoming exams, SSC, JE in the month of July or August. It is not confirmed yet. After that, we will also have so many upcoming exams, including GATE 2023. Sorry, 2024, next exam. So for all these exams, we are going to revise all the required formula. Especially, we are designing as of now. We will be focusing on only these two exams. After completing these two exams, again we will have one more complete revisions on SSC, JE, whatever the required subjects that are very important for SSC, JE. We will be focusing on that. After that, we will focus on GATE 2024. So let's start from the signals and system. As I observed that there are so many people are struggling in signals and system, especially from the particular areas, Fourier series, and the second one is Fourier transform. Even in Fourier transform, most of you are struggling to solve problems in continuous time domain. There is continuous time Fourier transform itself. So you must be very conscious. You must know all type of properties to solve all type of questions from here. Similarly, discrete time Fourier transform, you must aware of the basic formulas how to deal with this. After that, you must be very conscious with the Z transform. We will just follow the same sequence. After that, we will have a look into basics of signals and systems. So we will also be focusing on signals and systems. That's it. Now let's keep our attention with the first one, that is Fourier series. We'll be starting from Fourier series. So we know in Fourier series we are having so many classifications. Do I need to speak in Tamil? Okay, no problem. But you can understand now because some other state people are also watching this video. I don't know whether they can pick up. I'm using only normal English words. Try to catch. If you don't understand in any particular area now, you can just ping me once. I will try to re-explain if you are really unable to pick up what I'm trying to say. Okay. First, before starting this, as I told you, it's a complete revision type of classes. You must aware of all this basic concept already. So even if you don't remember the basics, first recollect once. Take some 30 seconds. What we studied in Fourier series, what type of classifications that you have studied, what is the meaning of Fourier series, specifically for what type of signals we will be applying Fourier series. So we are having periodic signal, we are also having aperiodic signal. So in which type of signals we will be intentionally putting our Fourier series, and we are trying to expand the Fourier series, and we are also having two types of Fourier series. One is called trigonometric Fourier series, and the another one is called exponential Fourier series. Be very well aware of this. One is called trigonometric Fourier series, and the second one is we will be focusing on exponential Fourier series. So first I will be completing Fourier series, then we will start Fourier transform, then we will focus on Z transform, then we will go back to basics. At last I will also be covering on basics of sampling theorem and all. Okay. Now tell me once what type of things that we have to cover. See, first thing, when we are focusing on trigonometric Fourier series. In trigonometric Fourier series, First of all, we must know the basic conditions in which, for example, if any signal will be given to you, and you have to apply Fourier series in order to know the internal properties and behavior of the particular signal. Then to apply the Fourier series for any signal, we will have a certain conditions. What conditions are there? So we will have certain four conditions. If your signal is not satisfied those four conditions, of course we may not be able to apply our Fourier series. Any type of, it can be trigonometric or exponential. This is common observation. First thing is, whenever you will be focusing on the Fourier series properties, the first one, if I am selecting a signal, that signal should be a periodic signal. First mandatory condition to apply Fourier series is your selected signal should be a periodic signal. Once your signal will be, once you identify that the given signal is a periodic signal, next thing you can apply, you can cross check whether this signal, though it is a periodic, whether it is having finite number of discontinuities or infinite number of discontinuities. So there will be a certain number, only it will be allowed to keep only finite number of discontinuities. What is the meaning of discontinuities? First of all, see, for an example, if I am selecting a sinusoidal signal, it's a periodic signal and it is running from minus infinity to plus infinity. When it is running from minus infinity to plus infinity, when you have observed that this signal is said to be a completely a periodic signal, then select only one particular period after which the signal is going to be repeating its nature. We know after 2 pi, sinusoidal signal will be repeating its nature again and again. So the first thing is select only one cycle after which nature of the signal will going to be repeated. Now identify in this specific period how many discontinuities are there. How many discontinuity? Discontinuity is nothing but zero crossing points. Don't think too much about it. It is simply, you can take it as zero crossing points. So how many zero crossing points are there for the given sinusoidal signal? As we are observing, it has only one. You can consider this one also, 2, 3. So totally we have 3 points, 3 discontinuities. Is it finite or infinity? We can call, this is called finite number of discontinuities. If your signal is having finite number of discontinuities, then yes, the signal is periodic and it is also having finite number of discontinuities, then condition number 1 is satisfied. That is, it should have finite number of discontinuities. Please write down, it should have finite number of discontinuities. If your signal is satisfied, then one condition is okay. And the second one, your signal, whenever you are selecting any signal, your signal should be absolutely integrable. It means if I am integrating the given signal, it should not give infinity. Your signal should give finite values. So your signal should be, if I am integrating the given signal with respect to time period, of course it should be absolutely integrable. Its resultant value should not approach infinity. That is very, very important. Otherwise, you cannot apply the signal. You cannot apply. Next most important point, your signal should have finite number of, so this is the first condition and this is the second condition, and the third one is your signal should have finite number of maxima minima over the given period. As we are observing the given period is, I am taking once again sinusoidal signal as the best example. If you are observing the given signal, how many maxima and minima are there for sinusoidal signal? If you are observing the sinusoidal signal, the number of maxima minima, how many number of maxima and minimas are there, sir? The maximum number of minima and maxima. Maximum means maximum point. At pi by 2, our sinusoidal signal will be approaching. Am I audible or not? Guys, please tell me. Your voice is very low. Can you increase a little bit? Still, the same problem is continuous. Hope. Okay, let me try to increase. Please everyone confirm once. Is my voice is audible or not? Okay, let's continue. So it has finite number of maxima and minima. If you observe sinusoidal signal at pi by 2, it is approaching its maximum value. And at if you observe at 270 degree, when it is exactly approaching 3 pi by 2, what's happening? Sorry, 5 pi by 2. What's happening here? 270 degree. At 270 degree, our signal is approaching to minus 1. If it is become -1, so totally how many number of maxima and minima are there over the period of 0 to 2 pi? The number of maxima are 1, only one maxima and only one minima is our sinusoidal signal. See, at 90 degree, it is having 1. At pi, it will become, obviously, it is 0 once again. After that, at 3 pi by 2, what it is approaching? It is approaching 270 degree. At 2 pi, again it is coming to 0. So it is having, over the given period, it is having only one maxima and one minima. So the thing is, it is having finite number of maxima and minima. If your given signal is having finite number of maxima and minima, then also absolutely you can apply this Fourier series. Are you understanding what I am saying? So your given signal must be a periodic signal, and next it should have finite number of discontinuities, and of course after that it should have finite number of maxima and minima, and it is absolutely integrable. Can every one of you understand? Do I need to speak in Tamil? Please let me know. Is it easily understandable, or do I need to explain everything in Tamil only? I am not using any critical words. Next, if you are observing trigonometric Fourier series formula, so that is the next most important thing. So when we are observing trigonometric Fourier series, how will you expand the trigonometric Fourier series, sir? The expansion of trigonometric Fourier series can be written as, suppose if a signal x of t is given in general, or some waveform will be given to you. That waveform can be theoretically represented or written in the form of trigonometric expansion. So the formula is a naught plus summation. What is the formula, sir? N equal to 1 to infinity. And what will you write here? We can write it as an into cos n omega t, an into cos n omega t plus bn into sin n omega t. That is how we are writing trigonometric Fourier series expansion. And here you must understand one more thing. We have to calculate the value of a naught, and we also have to calculate the value of an. Yes, and we also should calculate the value of bn. So these are only three more things while expanding a series with the help of trigonometric Fourier series. So how should I express all these terms? Do we have any separate formulas? Yes. So we have a separate formula in order to calculate the value of a naught, an and bn at all. So let me tell you, how will you calculate the value of a naught? If you are observing, a naught is, first of all, it is called average value. We are calling it as average value, and we can also call it as DC value, because we are exploring this value at a zero frequency. We are exploring this value at a zero frequency. It is zero frequency value. It means we know if your frequency of the signal is approaching to zero, then that is called what? DC signal. So trigonometric Fourier series is helping us basically, if any signal is the combination of DC signal plus fundamental and harmonics, it can be easily extracted. You can see its internal property. What will be the influencing or amount of DC value? What will be the value of fundamental and what is the value of harmonics? Everything can be expressed here. So A naught is this simply, A naught is DC value, or we can call it as zero frequency value, or it is also called average value. How will you express the formula is 1 by t integral of over the fundamental time period. You will have to explore simply x of t into dt. So you must calculate the value of average value. So that is the value of A naught. The next value is, we must explore Bn, An and Bn. I will tell you one by one, you just recollect. Next, when we are focusing on the value of An, usually value of An formula will be 2 upon t, integral of the period will be 0 to t. Just recollect everything, cos t into x of t into cos n times of omega t with respect to dt. That is the value of An. That is how we are exploring the value of An. Next, how to explore the value of Bn. The value of Bn can be written as 2 by t integral of same 0 to t. Formula is approaching x of t into sine of n times of omega t into dt. That is the value of Bn. Now, generally we know the formulas to calculate the value of A naught, A and B. But in the examination, especially if you are looking for some state exams, in GATE exam or if you are writing Barc or some big exams which will be having more duration or more marks, there some lengthy equations will be given. You will have to explore the value of A and A naught, B n separately. But when we are writing state exams, I will tell you, most of the times if you remember all the general properties of the signal, it is easy for you to give the answer directly in 30 seconds. So it is not necessary that you have to apply all these formulas. And one more thing, as I told you, for Fourier series we have four conditions. For Fourier series we have four conditions to apply. I only told it should be a periodic signal. It should have finite number of maxima minima. It should have finite number of discontinuities. It should be absolutely integrable. I only told all these conditions, but I would like to also tell you one more thing. Sir, suppose if I am asking, this is necessary and sufficient conditions to apply Fourier series. This is necessary and sufficient conditions. But if I am asking, is it mandatory? I can say it is sufficient conditions, or else you can also skip this word. This is sufficient condition. If you have these four conditions are satisfied, then you can apply Fourier series for that particular signal. Only remember like this, these are all called sufficient conditions. These are all called sufficient conditions. Can I call it as mandatory conditions? No. Mandatory or necessary. See, sometimes what they will use, they will use separately. You just write, these conditions are called sufficient conditions, but we cannot call it as mandatory or necessary, because sometimes this may leads to confuse. Mandatory or necessary conditions, they will use the word here. It is not mandatory, sir. I am saying to apply Fourier series on any signal, these four conditions are called sufficient conditions, but they are not called mandatory conditions. There will be a difference between mandatory and sufficient. You must aware of these two, because in one more questions directly they will ask you, in order to apply Fourier series, whether the given four conditions, or they will give these four conditions, are they necessary conditions? Do we need to mandatorily follow these things? No. If these all conditions are there, then that will be okay. That will be sufficient conditions to analyze the given signal. But if I am saying that is not, if I am saying that is mandatory, then you have to say no, it is not mandatory. It is not mandatory or necessary, but it is sufficient condition. Okay, that's it. So let's go ahead. That is type of one more questions they will ask. Now, as I told you, we must aware of the properties. If you are very good in properties, then you can easily crack all the exams. I will help you in that. Guys, if you are not feeling comfortable with the language, you can ping me directly. You can chat me in comment section. If you are feeling okay, if my English is okay, if you can understand the language, then we can let it to go, because it will be helpful for all other people also. Otherwise, I will speak in English. I will speak in Tamil. If you are not feeling comfortable in English, fine. What are the properties, sir? Property of a signal. When a signal will be given to you, that signal can be an even signal. That signal can also be an odd signal. That signal can be neither odd nor even signal. That signal can also satisfy the property of off-wave symmetric. That signal can also follows the hidden symmetry. So your signal will comes under only these properties. It will also follows hidden symmetry. So which one? How should I identify? If you are able to identify all these things, then it is easy for you to pick up the option directly without solving. It is very easy for you. How should I do it? First of all, we know even property means your signal should be symmetric about x-axis, about horizontal axis. If you choose this, your signal, so this is our y-axis. On x-axis, let us say there is a signal. That signal is flowing from left hand side to right hand side. And while crossing the origin, that structure of the signal will be like this. Always to knowing the property, to know the even property of a signal, select the origin, vertical line, this y-axis. From there, observe left hand side and right hand side of the signal is symmetric or not. If your signal is symmetric each other, if your signal is symmetric on both sides, similar on both sides, in that case, you can call that signal is an even signal. That is one type of signal. Sir, what else? If even signal will be given, then what can we do? Yes, I hope you all know some properties. Just let us recollect. Suppose, as I am observing that at the origin, our signal will be like this. Or your signal can also be like this. Either this condition or this one. If you are observing your signal will be like this, then that signal is called odd signal. This signal is reflecting the property. This is called odd signal. The above one is called even signal. If your condition is not satisfied, both of these properties, then that signal is called neither even nor odd signal. Let's continue. The first thing is, if your signal is an even signal, then the chances, the first thing, only A naught and AN will exist. The value of Bn will be strictly going to be 0. Now you can cross check your option. If your signal is an even signal, then you can cross check whether the value of Bn, there will be 4 options will be given. Definitely in 2 options Bn also will be included. If it is the even signal, then you can skip those 2 options because definitely Bn will be 0 for the even signal. First thing. And the next thing is, if your signal is an odd signal, then you can write definitely A naught is going to be 0 and the value of Bn will become not equal to 0 and the value of An will be equal to 0. So what you can observe is, if your signal is an odd signal, then strictly you can say that average value of A naught also will become 0, An also will become 0, Bn only will become not equal to 0. Once again cross check your option. Since the given signal is an odd signal, whether in the option only Bn is given or something else is given, based on that you can skip the option. In case of neither odd nor even, ultimately you should find all the properties A naught, An, Bn. But I am saying, in case of state government exams, questions will not be framed from this area because it will be time consuming process. If questions will be taken from this, you will have to spend some time to solve this. So in case in examination, you will have to solve the question within 1.2 minutes maximum time for question. So if it is comes under neither or nor even property, it will be a time consuming process. So most of the time questions will not be taken, especially if you are writing state government exams. So the another one is half-wave symmetric property. Let's see the another most important. What is the meaning of half-wave symmetric? Whenever we are focusing on half-wave symmetric, it will be dealing with the harmonics. Half-wave symmetric is basically dealing with the harmonics. What will happen, sir? Some harmonics will be approaching to 0. We are calling it as even harmonics. The value of even harmonics are approaching to 0. Some of you are confusing here. What if people are thinking, na? Even harmonics means suddenly your mind is linking with the AN. And if people are thinking that the value of AN will become 0, that is wrong. That is even symmetry. We played with the even and the odd values we observed. That is called symmetric signals. Odd signal, odd symmetry of the signal is different. Even symmetry, odd symmetry is different. Harmonics will be different. What is the meaning of harmonics? Numbers, the values 0, 2, 4, 6, 8, 10. This is called even harmonics number. Only this value will be approaching to 0. What I am trying to say, for example, if I am taking AN, this AN can be written as A0, A2, A4, A6, A8. All these values are going to be 0. That is the meaning of even harmonics set to be 0. Similarly, if we are exploring the value of Bn, B2, B4, B6, B8, I left to B6, B8, B10, all these values will be approaching to 0. That is the meaning of even harmonics will be 0. So whenever we are observing that the given signal is half-wave symmetric, if your signal is half-wave symmetric, directly you can say that even harmonics will be 0. Are you getting me? So finally, how will you conclude now? For an example, first thing, I'm observing that let us take a signal x of t. First, what you observed is that signal is satisfied, like the value of x of t and the value of x of minus t both are similar to each other. That is left hand side, right hand side both are similar to each other. It means you can write that the given signal can be treated as an even signal. If your signal is an even signal, then you will be writing that the value of Bn will be 0, sir. Only A0 under An will become not equal to 0. This is the condition you will write. After that, you are also observing that this condition, this signal is also satisfied one more property, that is x of t equal to minus x of t plus or minus t by 2. If your signal is satisfied the property of half wave symmetric, so this is the condition for half wave symmetric, then what you will be writing is, you already observed that the given signal is an even signal. So you observed that only A0 and An will exist. Even in An also, who will exist? If your signal will be satisfied the property of half wave symmetric, if it is satisfies the property of half wave symmetric, if this condition is satisfied, then you should write that all even harmonics values are approaching to be 0. So you will have to write the formula. In this case, the x of t can be in resultant, the value of x of t can be expressed as, if your signal is said to be satisfies the properties exactly, then the value of a0 also will be approaching to 0. So it will become n equal to 1, 3, 5, etc. approaching up to infinity. And here you can write, this is the formula, an into cos n omega t will exist. By observing this property, easily you can predict only one option will satisfy with this. Definitely only one option. You no need to calculate the value of an to solve this question. Similarly, the second type, you observed that the value of x of t is satisfied the another property, like the value of x of t and the value of minus of x of minus t are both same. If they are same, then you know that this signal can be treated as, it satisfies the properties of an odd signal. I can write that in case of odd signal, only the value of Bn will become not equal to 0. The other people definitely will be approaching to 0. These two people are going to be 0. If this is the case, further what you can say is, you will have to cross check whether half wave symmetric will be available or not for the given signal. If it satisfies the half wave symmetricity property, then what you can say is, once again, or even harmonics will be approaching to 0. So Bn will exist, undoubtedly Bn will exist, but where the value of n will be only odd values, you can consider 1, 3, 5, 7, etc. Just cross check only these things. It is very easy for you to give the final answer instantly. You don't need to spend much time on this. So the thing is, finally, from this, what do you say? So the value of resultant expression can be written as summation n equal to 1, 3, 5, etc. up to infinity. You can write the resultant answer as Bn into sine n times of omega t. Got it? This is how we are writing the final answer in case of half wave symmetric. So what you have to do is, whenever Fourier series will be given, always try to apply the property, whether it is comes under even property or it comes under odd property. Definitely, especially if you are looking for TRB and the state government exams at all, or any AJE, SSC, JE, RRB exams, or TSPSC or UPPCAL, whatever the exams you are looking for, it doesn't matter. In state government exams, I told you, there is one more case, neither odd nor even signals. For those type of signals, from those type of signals, questions cannot be directly framed. So just always cross check what property is behind of the signal, whether it is odd or even, after that half wave symmetric. If you figure it out, then it is very easy for you to catch up. And the next thing is, I also told you, hidden property. In some signals, you cannot directly observe whether the given signal is odd signal or even signal. For an example, I will tell you, let us assume there is a signal and it has been given like this. If a signal is traveling like this, anyone can you please tell me what type of signal it is? Whether it is odd signal or even signal. Let's see how many of you are trying to find the answer for this. If a signal will be given and you will be requested to find out the trigonometric Fourier series, what will you say, sir? Whether it is the even signal or odd signal? Anyone? Can you try and tell me the answer? As you are observing that the signal is not, it seems like it is neither odd nor even. Neither odd nor even. But that is not the truth. What you have to do is, just to shift the x-axis. If you are shifting the x-axis, then that will clearly tell you what properties begin of this. See there, I'm just shifting this x-axis here, exactly at the middle of the signal. If you are keeping like that now, then you can easily identify that what properties begin of this. See that now if you observe, this off and this off are similar to each other. So the odd property of this signal, that is odd symmetry, the given signal is having odd symmetry. It has been hidden, sir. It has been hidden. From this, what you can conclude, in case of odd symmetry, you know only Bn will exist. But remember one more thing, in this question, the value of A0 also will become not equal to 0. Why does it? Why it is? Because it is hidden symmetry, but it doesn't mean that you can keep the signal like this and you can continue the operation. No, you should not continue the operation like that. You will have to identify the hidden symmetry only. You can't say that average value will become 0 here. A0 will not be 0 in case of hidden symmetry property. So you can just cross check what symmetry will be satisfied here, whether it is odd symmetry or even symmetry. Based on the conditions, if it is even symmetric after switching, just to shift your x-axis and keep that line in the off of the signal. If this is the complete signal, na, just exactly put that line in the middle point, the center point. Then you can easily realize whether it is even signal or odd signal. Based on that, you can decide whether AN exists or BN exists. But don't touch A0. A0 will not be 0 in this case because average value will not be equal. Means positive and negative area are not equal here. So definitely A0 will exist. It will not be 0. Hope you understand. So if you remember all these properties, then it is very easy for you to solve the question when it is comes from, when the questions will be framed from Fourier series, especially trigonometric Fourier series. Okay. Hope you all remember, you will not be forget this. And one more thing, what you have to observe is, as I wrote, repeat one more time, what I wrote is, in case of trigonometric Fourier series, the signal can be written as A0 plus summation n equal to 1 to infinity. I can write here an into cos n omega t, and here I can write bn into sin n omega t. Yes, we can write this. And if you observe, this is at n equal to 0 point. And this one is running from n equal to 1 to infinity. What is the conclusion? The overall range of n in case of trigonometric Fourier series is simply n equal to 0 to infinity. This is called positive frequency range. This is called positive frequency range. It means trigonometric Fourier series is dealing only with the positive frequency. Trigonometric Fourier series is dealing with only positive frequency. Now, if you are observing the other series, I will tell you. So, you just remember, trigonometric Fourier series is dealing with only positive frequency. Let me continue. Now, the another Fourier series, there is one more Fourier series now, so that is called exponential Fourier series. The another one what we are having is called what? Exponential Fourier series. So when we are playing with the exponential Fourier series, we must be careful that, see, first thing, write down the general formula. The exponential Fourier series can be written as summation of n equal to minus infinity to plus infinity, sir, right, into Cn into e power j times of n omega t. Now here, if you observe, first thing what you must observe here is the range of the n will be approaching from minus infinity to plus infinity. It means it is dealing with the positive frequency as well as negative frequency. So exponential Fourier series is playing with both positive and negative frequency, whereas trigonometric Fourier series is playing with only positive frequency. That is the major difference that you must observe here. And the next thing is, what is the formula to calculate the value of Cn, sir? I will tell you. The next thing is, if we are trying to explore the value of Cn, what is the formula? Same formula, 1 by t integral of x of t into e power minus j times of n omega t into dt is the generalized formula to explore the value of Cn. After that, we have some properties, some special properties for this. Anyway, as usual, you must aware of this only formula whenever you are playing with the exponential Fourier series. Here, most of the time, how questions will be framed is, a signal will be given and you will be requested to calculate the coefficient. What you are trying to say, I will tell you. See, for an example, let us assume that a signal is given that x of t equal to cos 2t plus sin 3t. This is the given. Now from this, how will you find out the Fourier series coefficient? The question is any one Fourier series coefficient they will ask. Like find the value of coefficient c minus 1, or find the value of Fourier series coefficient c plus 1, or c minus 2, or find c plus 2. Like that question should be framed. You must aware of this. How should I know? How should I do this, sir? Very simple. For that, you should know the expansion, Taylor series expansion or Euler expansion of cos theta. How can we write cos theta, sir? Cos theta can be written as, from the complex series, this can be written as e power j theta plus e power minus j times of theta by 2. That is how we are writing cos theta. Similarly, if you are writing sin theta, sin theta can be written as e power j times of theta minus e power minus j times of theta upon 2 times of j. That is how we are writing sin theta and cos theta. Just remember these two formulas, that is enough. And the next thing is apply those formulas here. But before applying the formula here, you must aware of one more thing. What? One more thing, sir? The one more thing is, I will tell you now. Fundamental frequency. If you don't find the fundamental frequency, then once again you will be stuck in. Which one will be the fundamental frequency, sir? How can I calculate this here? So whatever the signal that will be given here, now first thing, see the first one. You can take the first one can be treated as the fundamental frequency. Directly you can take the fundamental one or omega naught, omega 1, whatever you can take. The fundamental. In the examination, most of the time they will be writing omega naught like this. Sometimes the symbol for omega they will use ohm symbol. Don't get confused. Okay, for discrete domain, especially for discrete domain, they will use the symbol like this. For that, it is also representing the omega only in signals. Is equal to, let us take, see, cos omega t. Let us assume this is your fundamental radian per second. Okay. After that, now let us explore the signal. How can I explore this signal, sir? Cos 2t plus sin 3t can be written as, let me write. So the value of x of t equal to cos 2t can be written as e power j times of 2t plus e power minus j times of 2t by 2. Yes, plus sin 2t, sin 3t. Sin 3t can be written as e power j times of 3t, of course, and plus, sorry, minus e power minus j times of 3t. Yes, that is done. And see, do one thing, one small correction. Here they will not give 60. I took wrong value for frequency, that is not possible. Give 6. Okay, fine. 6 divided by 2 times of j. Now let's continue. So this can be rewritten as 1 by 2 times of e power j times of 2t plus 1 by 2 times of e power minus j times of 2t plus this can be written as 1 by twice of j into e power j times of 60 minus 1 upon 2 times of j into e power minus j times of 60. Sir, after writing this, how should I explore the coefficient? That is very easy. You have written everything here. Write down this general formula for Cn. See, while writing the Cn, the formula how we are writing 1 by t integral of x of t into what we are putting here? E power jn omega t minus 3 power minus jn omega t. This is how we are writing. So here basically what we are doing here is n times of omega. With the frequency we will have the value of n here. With the frequency we will have the value of n. So that is what you have to remember. From this general observation, whenever they are asking a Fourier series coefficients, only focus on the power. See here, what we are having is, we know the fundamental frequency omega equal to 2. And remember that the coefficient should be written in this format, jn omega t. So if omega equal to 2, then what will be the value of n here? So definitely the value of n will be approaching to 1. Then only you will be getting j2t here. So from this I can say the value of n equal to 1. So the value of c equal to 1. Cn, c1. So here, whatever the coefficient that you are having, this is exponential Fourier series, sir. This is exponential Fourier series. Remember, there is one more formula, x of t equal to summation n equal to, you should remember both formula, n equal to minus infinity to plus infinity e power into j times of n into omega t. It's better you directly, I am writing this standard, sorry, direct formula. I wrote Cn formula, C. So this is from this you will have to compare this with this one. If I am comparing this, in place of n I have 1. If here you are putting 1, then here also you have to put 1. So C1 equal to whatever the coefficient that you are having in front of exponential term, that is the value of C1. So from this I can say the value of C1 equal to 1 by 2. Now if you observe the second one, here we have j times of, in place of n we have minus 1 times of 2. Omega equal to 2, that is our fundamental frequency. So C minus 1 equal to its coefficient. Its coefficient is what? So this is C minus 1, that is equal to 1 by 2. Similarly, you can find the second one. See, here we have 6. 6 can be written as 2 into 3. 3 is our fundamental frequency. So n equal to 3 here. So I can say n equal to 3. So at n equal to 3, what is the coefficient? We have 1 by 2j. So the next coefficient is C3 equal to 1 by 2j. Similarly, can I write C minus 3 equal to minus 1 by 2j, sir? Minus 1 by 2j is what you can write. If they are asking in the same series, if they are asking you to calculate the value of C2, what will be your answer? Answer will be 0 because C2 is not there. See there, we found that at n equal to 1 we have these two. At n equal to 3 we have another 2. So C2 is not there. So C2 and C minus 2 both will become 0 here. That's it. That is how we are finding the coefficients when a signal will be given to you. Now, you should remember one more most important relations between trigonometric Fourier series coefficients and exponential Fourier series coefficients. What is the relation between trigonometric Fourier series and exponential Fourier series coefficients? And of course, how can we write down these two? So the most important thing you must observe here is, let me write, if I am observing, suppose let us assume that I am having the value of an and bn. It has been given in the question. And you will be requested to calculate the exponential Fourier series coefficient Cn. Then the formula will become Cn equal to, what is the formula, sir? An minus j times of bn by 2. That is the formula. Similarly, if you want to know the value of C minus n, remember C minus n is nothing but Cn conjugate. Where is Cn? This is Cn. Conjugate means imaginary part sign will change. If I am taking conjugate, then this can be written as an plus j times of bn by 2. That's it. That is how we are writing C minus n. Now you know how to calculate Cn minus n when an and bn will be given. By solving these two equations, see, just add Cn with the Cn conjugate or C minus n. If you are adding these two values, now what you will be getting, sir? You will be getting an directly. So if exponential Fourier series coefficient Cn is given, then how should I explore the value of an? This is the formula, Cn plus C minus n or Cn conjugate. How will you calculate the value of, subtract both two? See, Cn minus C minus n conjugate, C minus n. If I am subtracting both of these expressions, then what will be getting? An by 2, an minus an by 2 will get cancelled, it will become 0. So minus jbn by 2 plus minus jbn by 2 will become minus 2 times of j bn by 2. Anyway, 2 will get cancelled. If you are passing this minus j to the right hand side, no, this is, sorry, left hand side, this will become j times of Cn minus C minus n. So this is the formula to calculate the value of bn, and this is the formula to calculate the value of this is the formula to calculate the value of an. So you just aware of these two. Okay. So these are the most important things that you must keep it in your mind regarding Fourier series, trigonometric Fourier series and the exponential Fourier series. Guys, tell me, is there any doubt till now? Is there any doubt? Is it really helpful for you all? Is my voice is clear and everything is fine? Please confirm once. None of you are chatting in the comment box, but I am seeing there are so many people are in live. Can you all please respond? Okay. So voice is great. Voice is fine now. No. Done. So this is all about Fourier series, and in the next session, what we are going to discuss is. So we have completed whole Fourier series here. In the next session, we will have to see the properties of Fourier series coefficient, not whole thing. For Cn, we have some properties, most important things that you must know. There are some questions will be directly taken from the properties of this, After that, we will directly start Fourier transform. First, we will deal with the continuous time Fourier transform, and second, we are going to deal with the discrete time Fourier transform. And I am requesting you all to please join in the live session only, such that if you have any doubts, you can directly ask in the comment section itself. I will be here to help you all. I heard that most of you are facing a problem, especially in signals and system. After that, analog electronics. So here I framed the sequence of the subject in such a way that it will be helpful for you all to understand the properties of all series, transform, and some of you who are doing self-preparation, you may not be able to identify the exact zone. Like you might be studying so many things, but still there are some portions which are very important for the exam, and you might not study it yet. So those things also I will be covering here. So by attending the classes, full sessions regularly, you will come to know if you left something that you can easily identify, and I will also help you in some areas. Properties are very easy, but you may not be able to get the answer. So there I will guide you how questions will be usually being framed, or how questions will be tested there. So I will help you to keep the tricks in your mind and important formulas. You can easily apply that in order to crack the exam. Okay. So with this, let's wind up the today class. In the next session, I will come up with the next properties of Fourier series coefficient and Fourier transform. Thank you all. If you have any issues beyond this, please chat me in the comment box. You can upload whatever the things that you are expecting. And as I told you that I will be using very easy words. I am going to take this whole series in English only, because there are some other state people who are also seeking for our help. Meanwhile, if you are not understanding some things, I am ready to explain in Tamil also. For example, this portion I don't understand, sir, this formula or something. If you want, if you are expecting me to explain in Tamil, definitely I will do that. Okay. And in that time, for that you should be in live, should be exactly follow me, and there will be no any delay between us, such that you can ask your doubts without any gap, and there itself I will explain. Fine, let's end up this session with this. We will meet in the next session. Thank you all.